Let's go to talk about chapter 7.3, basic counting principles. This is a small summary of what we will cover in this section. We will talk about the addition principle, how to create Venn diagrams, which is the most important, and the use of the multiplication principle. So a Venn diagram is a technique that is used for picturing set relationship. First of all, we may have disjoint sets, so two sets that they don't have any common elements or no elements are in common are said to be disjoint. And here you have the two sets that they don't have any common area. In this case, since there's no overlapping, the intersection between the two sets will be 0. They don't have anything in common. In this case we have overlapping sets, and this is the common area here. So this area represents the elements that are in the intersection of set A and set B. Complement of a set. The set known as the complement contains all the elements of the universal set which are not listed in the given subset, and the symbol is A prime. Again, for the intersection contains only those elements that are common to both of these sets. Keywords. These are the two keywords to understand if you have intersection. If you see A and B, or if you see A and B both, or both A and B, then we talk about intersection. And this is the symbol for the intersection. Union. The union unites, that means brings together everything into one set. The keywords are or at least. So if you see A or B, intersection before was A and B, or if you see A, at least A, or another statement at least B, that means A or B or both. That means union. And this is the symbol for the union. It's like a U. Now, the number of elements in two sets. So to find the number of elements in the union of two sets, you have to add the number of elements in A plus the number of elements in B minus the number of the intersection. This is known as the cardinal number, but again that indicates the number of elements in two sets if you have a union. Number in A plus number in B minus the intersection. Let's go to see an example how to create a Venn diagram. So in this case we have a sample of 120 people where we found that 74 liked the regular, 62 liked the mint, and 35 liked both flavors. And this is the question: how many they liked only the regular, how many they liked the one or the other, and how many people did not like either flavor. In the Venn diagram, the first step that you have to do is to find the people that they like both, starting with the intersection. So you have 35 people that they like both. And then to find how many people they like only regular, you have to subtract 74 minus 35, and this is 39. And to see how many people they like only mint, you do 62 minus 35, which is 27. Don't forget, 74 like regular. From this 74, 35 like also mint. That means they like both of them. So let's go to see the steps. So one more time, we have to start with the people that they like both. So 35 people like both flavors. And then area 1 goes to the people that they like only regular, and area 3 to those that they like only mint. So you have to find the difference between all the people who liked each toothpaste and those who liked both. So here we are. We have 35 people that they like both, 39, which is 74 minus 35, they like regular, and then 62 minus 35, 27, that they like only mint. Don't forget, if we go back, you can see that we have 120 people in the sample. So if you add 39, 35 and 27, this is 101. So 120 minus 101, there will be 19 people that they don't like regular or mint. So from here, these are the answers for the questions for the problem. As you see, 39 they like only regular, and this is the answer. For the next step, we have 39 plus 35 plus 27. This is 101, and this is the union. So what we do, we add 39 plus 35 plus 27. However, if you want to use the formula, let me go back a few slides. You can add 74 plus 62, which is 136, minus 35. And this is by using the formula. So 74 plus 62 minus 35. And the answer, of course, is going to be the same. So you have two ways. Or you add 39, 35 and 27. So 101 people, they like both. Or you follow the formula. So you do 74 plus 62 minus 35. In any case, the answer is going to be 101. And then finally, how many people they didn't like mint or regular? We have 101 that they like the one or the other. So you do 120 minus 101, 19. Let's go to see a second example, which is very similar to the first one. Again, we have to start with the 7 students that they have a major in psychology and English. So this is going to be the intersection. So 23 minus 7, 16 have a major only in psychology. 16 minus 7, 9, they have a major only in English. And we have 50 students. So how many they majoring in neither of these subjects, and how many students they major in psychology only? So this is how we start. We start with the intersection of the 7 students, and then we figure out how many they like English only and psychology only. So 16, 23 minus 7, major in psychology only, and 9 major in English only. So again, you can do 16 plus 7, 23, plus 9, 32. We have 50 students, so 50 minus 32, then 18 don't have a major in psychology or English. And these are the two problems for the Venn diagram. Of course, tomorrow I will give you some more exercises and we will go through them. But you have to know how to do now the Venn diagram. Multiplication principle. Let's go to see this example. Assume that you have 4 pairs of trousers, 3 different shirts and 2 pairs of shoes. Assuming that you must wear trousers, a shirt and shoes, how many different ways can you get dressed? So first of all, let me give you some colors for your trousers, black, gray and so on. So you have actually 4 choices. And then I give you the colors for the shirts. So for each pair of pants, you have 3 options for shirts. So you have 12, which is 4 times 3 options to wear a pair of trousers and a shirt. Then don't forget, you have 2 pair of shoes. So you have to multiply 12 times 2. So actually you have 24 options to get dressed. So simply you multiply the different options. 4 times 3 times 2. And this is going to give you a total of 24. You can create a decision tree, and this is how the decision tree is going to look like. Again, you multiply m times n times p. Decision tree, you will cover it more in POM 333. This is the second example. How many different ways can a team consisting of 28 players select a captain and an assistant captain? So, if all team members are eligible to be a captain, you have 28 ways. Then, under the assumption that the person now is a captain, then you have 27 choices for an assistant captain. So what you do, you have to use the multiplication principle. So you have 28 times 27, 756 ways to select both a captain and an assistant captain. And if you have any other position, then you have to multiply by 26, because already you have a captain and an assistant captain. The third example, let's say that someone has to rank 8 teams in the ABA from the first to the last. How many different rankings are possible? We start with 8 teams, so you have 8 choices that can be made for the first place. Now, for the second team, you're going to have 7 choices. For the third team, 6. For the fourth one, 5, and so on. So what you have to do is that you have to take the product of 8 times 7 times 6 times 5 and so on times 1. So the answer is 40,320.